Well, good morning, everyone. Thank you for, number one, attending Things Expo, and thanks for taking the time to spend the next 25 minutes with me talking about BSquare and our offering called DataV. I'm going to spend the first few minutes talking a little bit about our company because I think that historically we've been around for a long time, but not many people are familiar with us and understand why we're here at the conference talking about IoT solutions. So I want to give you a quick background of that. I want to give you some information around what our product actually covers because it's actually a very wide space of technology that we're trying to address here with the DataV product, and then show you an example about how we do this specifically in our software to enable some of these IoT use cases. So for us at BSquare, we've been around for 20 years. We're a publicly traded company. Our history has always been in embedded software. So it's important for me to get across, we're not a hardware company. We've always been in the software space, but doing interesting things on devices. And so for us, if you believe that every IoT story starts with a smart connected device, and BSquare has been doing that probably longer than most people in the industry. If you look at some of the companies that we've worked with in the past, you'll see it's a wide range of industries. And for us, we think that's important because the technology that we're talking about in terms of IoT does have applicability across a wide range of industries and devices and use cases. You know, one example I like to point out that we've been involved with is Coca-Cola. So if anybody has seen the Coca-Cola Freestyle machine, which is that sometimes in fast food or quick serve restaurants, it's the Coke machine soda fountain with the touchscreen interface where you get 100 different drinks out of a single machine. That's a project that we felt at BSquare, well, number one, we delivered all of the software for that to Coca-Cola, which has been a great long-term customer to us. But for us, it was also one of the first examples of us doing things that felt very IoT related. And the reason why I say that is because it wasn't just about putting a smart machine in the field and being able to collect data off of it, but it was also about, what is the value that they could get off of that data? And it falls into many different areas. I mean, for Coca-Cola, it was very important for them to understand things from a marketing perspective about, what types of flavors of drinks people are purchasing on what basis to help them refine perhaps what their product strategy is. They also looked at it from a remote maintenance perspective as well. I mean, as these machines get more complicated and go out into the field, it's also required a higher level of expense from them in terms of, how do you maintain and manage and do maintenance on these types of machines. So for them it was important. In the local area here, Google has been a great customer for us. We're involved in a couple of different Google-related projects, mainly in the ATAP group. So anybody familiar with Project Tango, which is the 3D imaging phone, BSquare has been one of the partners, and if you go on the Project Tango website, you'll see some of the examples of the work we've done with Google on that. The other project we've been involved with at Google, ATAP, has been Project Aura, which is the modular cell phone platform. So again, kind of the point I wanted to get across with a little bit of this BSquare background is we've been in the embedded space for a long time, we've got a lot of trusted customers, and we've done interesting projects with a lot of big name companies across a wide range of industries. And so, whereas the BSquare name previously may not have been necessarily very recognizable, we've been an ingredient in many solutions, many products that you probably are already familiar with. So for us as a company, we focus on three major areas. We've got a DataV product line, which is specifically built around Internet of Things solutions. And I will dive into a deeper part of that in a moment. Equally as important to us is we have a full professional services arm that can help businesses understand and walk through the ideas of what is it that they're trying to accomplish with an IoT solution. And then also, how do we take it and integrate it into their existing business? I think that's becoming increasingly important because of the fact that IoT, more so than even other previous initiatives in the past, really involves the lifeblood of these companies, which is their data. And so now we're no longer talking to just a particular product group, but we've got IT involved, we've got operational guys involved, legal is certainly concerned. And so how can we, as a provider of both software and professional services, help companies navigate those waters and help build solutions that apply not just to one group within their company, but holistically integrate it into the rest of it. So let's talk specifically about DataV and what its mission is and what we're trying to solve with it. So DataV is all about helping businesses improve better business outcomes through the use of IoT. Now for us, this falls into a couple of different categories and different things. I mean, you'll hear people talk about, which I completely agree, three main areas that people are looking at when it comes to IoT solutions. Either they're looking at this as a way to help them reduce costs, or in some cases look at ways of improving revenue through potentially new business models and new offerings that they may not have been able to offer in the past. Equally important for me is what I am seeing customers talk about is the need for more differentiation. I've been out over the last year or so talking to companies in a lot of different industries who have said to me, our products that we've offered today are starting to feel more commoditized. One, for example, was a smart meter company, these kind of electric meters that would go on the side of a residential house. They used to be an industry leader in their space, but now they're having a harder and harder time really standing out. And so they're looking at IoT as a way of either A, delivering more functionality for the same price to their existing customers to keep them engaged with the company's offerings, and also too looking at new ways of doing business models and service offerings. Now, they're a great example of an OEM, so somebody who's building devices and communicating those out to the world. And so for people who are building devices, things like warranty costs are incredibly expensive. One of the trucking companies that I've talked to, I think was upwards of $300 million a year that they have to allocate on their balance sheet just to cover warranty expense. And so anything that we can do to help increase uptime of those vehicles, or do things in terms of reducing the amount of times to diagnose and troubleshoot and fix an asset in the field, is all driving value to them. So that's the motivation of what we're trying to do, the whole reason why we believe IoT is important in the industry, and why we think that technology is an important part, but not necessarily the forefront of what companies should be thinking about. These are the things, so this stack that I'm putting on the screen is exactly the components that I believe, and my company believes, are important to deliver a complete solution. We've mapped this out very specifically because we see other people in the industry focusing on different areas. There's lots of companies that are very good at analytics, and there's lots of companies that are doing a lot of interesting things on unique hardware boards and devices. But you don't see very many people helping customers understand how to put together a complete solution that involves that complete gamut of information. And I think that customers, at least the ones that I've been talking to, are feeling a little bit frustrated with the fact that they don't have the skill sets, they don't really understand what it is that they need to accomplish to do this, and they don't want to have to go to 10 different vendors to piece together a solution. So BSquare is addressing this by not only offering that guidance in terms of helping customers understand what it is that they might want to do, but also backing up that with the technology components that are required to deliver on that promise. And so for us, there's those three main levels. On the device itself, it's not just about connectivity. And if you heard me speak yesterday in any of the main sessions, you'll see that I probably made a few enemies in the cloud community because I said, the cloud isn't always available in a lot of IoT environments. I think the cloud is very important. It's one piece of the puzzle. And I do think that it will play a part in many of the IoT deployments that are out there. But when you specifically look at some of the industries that I'm talking about, you're dealing with situations where either bandwidth isn't always available, or it's very low bandwidth, or you have issues around latency, just the time it takes. So this idea of saying that you're going to take the data, you're going to move it to the cloud, wait for the cloud to make a decision and come back, doesn't always work. You need to be able to have some autonomy, some way of being able to look at data and process rule sets on the device itself. And that's what I'm trying to depict on this diagram here when I duplicate these modules that we talk about. So things like connecting devices, monitoring the real-time data streams, creating actionable events, driving automation through the process, and then layering on analytics components in terms of both predictive kind of analytics as well as optimization analytics. All of these play a part. And the reason why monitor and automate are duplicated both in the cloud, off away from the device side and on the device itself is just a testament to what we're trying to say. We've got the technology to drive that in both places and do it in such a way that they work together. And for us, coming from our embedded background, I'm not limiting this to just what I would call big devices that could run a full operating system like embedded Windows or Linux or something like that. I'm talking about very small sensors where our footprint is something like 90K, but still being able to drive this automation and intelligence on the device. I think it's an important part of what's going on, and not enough people, I think, today are paying attention to that. I think as the volume and scalability requirements continue to grow for IoT solutions, you're going to see people, you're going to remember this presentation, you're going to see people come back and say, hey, that guy from BSquare, he was on to something about intelligence at the edge. with our limited time, what we do when we go through engagements with customers is try to map out, what is the use case that they're looking to do, and how does that fit into that software stack. So if I was to tie those two conversations together, you'll see that depending on what you're trying to do, it's different modules of the stack that we might implement. And from our perspective as a company and as a vendor, we recognize that interoperability and open standards and flexibility is key to surviving in the world of IoT. For one, you're never going to walk into an environment where a customer has nothing. And so for us, we're very friendly as far as being a vendor to say, if you have an analytics solution that's working well for you, and you just need help on the other portions of the stack, great, we can deliver just those components and do some of that integration work to make the pieces work together. Likewise, we see customers that are the opposite, where they've figured out how to get device data back and they're showing it in a dashboard, but they're not getting any more value of it other than just seeing the data. And to us, that's not enough. You want to do things like smart diagnostics. You want to switch from reactive maintenance to condition-based or predictive maintenance. Things like optimization is becoming more and more important. And to me, when I say optimization, I'm talking about building data models that can accurately reflect what a well-behaving piece of equipment looks like, and then not just look at and identify devices that aren't in compliance with that standard, but actually going a step further and actually coming up with prescriptive steps that would remediate that situation. And then by driving back down through the stack, you can automate, perhaps, in situations where you have enough capability on the device, almost a self-healing concept. And so I've got two different slides, and we do have a booth over on that side of the floor. So later, when if I run out of time, you can come back. I'm more than happy to discuss some of these use cases further and how they work. Some of the key design principles that we went into when building DataV was to make sure that we followed a product-based approach. Historically, as a company, we've done projects in the past that were all completely services, but we felt like it was in our interest and in our customers' interest to be able to bring true productized components where you get a roadmap, you get supportability, and you get the ability to reduce time and risk in a deployment by jump-starting yourself with off-the-shelf components and then wrapping around the integration portions that you need to deliver on the solution and the business outcome that you're trying to achieve. For us, this wasn't a product that was built from a merger and acquisition, and it's not a legacy product that was repurposed for IoT because that's a new buzzword. It's for us, if you think back to what I said earlier, 20 years of experience in embedded devices and understanding the connectivity and the data requirements for those led to us to determine what we felt like were the best practices and the things that most companies that we saw in common across that wide range of industries all needing to do to achieve these goals. And so we took those and built those into those product modules that I discussed. Distributed intelligence, I think I already discussed. The idea of cloud and local rules on the device are both equally important. The concept of you don't need to have a data scientist and you shouldn't need to have an engineer every time you want to take advantage of one of these situations. And so for us, we sort of say internally, we want to hire the data scientists so the customers don't have to. And that's the way it should be. You should have easy to use graphical tools that allow business and line of business people to make logic and business choices that then affect the system and not have to go back to IT or have a programmer make those changes. It's an important design concept for us. And then of course, what we said about, or what I said earlier about just being modular and standards based. So if we think about a current deployment scenario, it might look something like this. You have an asset in the field that's collecting data. It needs to send that data back to a particular location. What's important to me, I think, when I see customers doing interesting things with IoT, is it's more than just device data. IoT, of course, lends people to think about device data because that's the new data source that I think a lot of people haven't taken advantage of in the past. But to me, the best IoT deployments are ones where you're really combining three different data sources. It's the data on the device itself, it's your other existing enterprise data sources that you already have, and it's public data sources, things like weather and other things that you can get online. It's really the combination of all of those that I think drive the best scenarios. So if we were to walk through those sort of different layers and how that all comes together into a complete IoT solution, this is the first step. You need to be able to surface and expose that data, and we provide that component to be able to do that. But this is also where I feel like a lot of companies stop. They get the data, they bring it back to a central source. It's a hard thing to do, and they're very proud of it, and I'm proud that they do that as well. But then they put it in a dashboard, and they say, okay, great, now we've done IoT, now we're done. in my mind, you've only just begun. What you want to do, if you believe any of the numbers around IoT and the number of devices and the growing complexity and just the explosive amount of data that's going to continue to grow from those locations, doing things in a manual way where people watch dashboards and try to take action based on that isn't going to scale. What you need to be able to do is drive automation into the solution. And again, from the data V and BSquare perspective, that's automation both in the cloud and on the device itself. And then finally, how do you layer on the analytics pieces and really close the loop on the situation? It's not just a one-way flow of data. I think that the best situations are two-way. And so that's my as quick as I can overview of what we're trying to do with BSquare and what the product is, Data V, as far as the components. Now, a key tenet to what we're doing, and the thing that I'll probably continue to reinforce over time, is this idea of scalability. And how can you not make one of these solutions become an unmanageable burden onto your company? So, this idea of saying, automation, whether it's rule set and logic automation on the device, and then also the process of how you even determine those rules. So, I talk to a customer, and you'll find some of them like this, who are very adamant that nobody knows their devices better than them, and so they want a manual way of building all the logic that would happen to that. And BSquare certainly provides the graphical tools to be able to do that. But very quickly, these customers typically transition to realize that there's just too much data and there's just too many things that a human himself couldn't figure out how to handle that. So how can you then take advantage of the advances in things like machine learning to help effectively automatically derive what some of those rule sets and then use that as an input into that automation process? So what I'm going to do now is sort of walk through a quick example of how BSquare does that. So now we need to do a little, put on our imagination hat and think about the scenario that I'm going to provide, because it's kind of difficult to demo that entire stack in a small time window. So I'm going to try to give you one piece of how we do some of the analytics and how that drives rules. So in this particular case, this came from an actual real-world situation where we talked to a company that was doing commercial kitchen equipment, and one of the things that this company built was a smoothie machine. So a smoothie machine or a milkshake machine, however you want to think about it. But it was their concerns as a company were a couple. One, of course, they were interested in how do we improve the uptime of that machine and how do we guarantee that that we can fix it in a quick amount of time so that it doesn't go down during lunch rush when everybody's trying to get in on a hot day, kind of thing. But equally important to these guys is they sold into franchises restaurant franchises where things like consistency were very important. So we look at the data set that they gave us to start looking at it. It's only a few columns, so it's a very simple data set. In fact, you could probably do some of this analysis by hand, but you'll see very quickly that if you were to imagine instead of 3 or 4 interesting rows of data, if you had 400 or 500 interesting rows of data or columns of data and then millions of rows, it's going to become unmanageable pretty quickly. So the concept here, though, is we have a smoothie machine, and what we want to do is we want to make sure that smoothie machine consistency of the output of the nozzle that's going to go into the cup is always what it should be. And part of this was even determining what that value should be. And there's some influencing factors that affect what happens. So you've got different components and sensors within the machine. You've got a sensor on the nozzle that's taking care of what is the actual output temperature. You've got syrup storage tanks and things like that. So when the customer gave us this data, the BSquare process is to put that into our Data V engine and create a data model of what it looks like. And so one representation that we use to look at that is this diagram. So this diagram is effectively a visualization of a data model based on the behavior of that device that we were to derive off the data. So this was a completely automated process, no humans involved. And the way that you read this is that in the center of the diagram is what we know without including any other external factors. And what I can say if you look in the upper left is that we're predicting that the temperature nozzle temperature with no other factors involved will be 38 degrees with a mean squared error of 8 or 9, depending on which of the test data or the training data you want. So to me, that's a huge swing. That's too much. I mean, just imagine the difference between a 38-degree smoothie and one that's 8 or 9 degrees higher or lower. That's a consistency problem. So the challenge is, what can we do to try to figure out how to make that prediction better? And as you move away from the center of the diagram, you start noticing that different factors are starting to take into play. So if we go to the left and we look at what's saying, well, that storage syrup storage sensor is one of the things that we can look at. When that thing is over 39 degrees, the prediction value, if you look at the error rates, even higher. You're going in the wrong direction. This thing is going to get even more out of control and less consistent. However, if you move to the right of the diagram, you notice that now we went from a mean squared error of 8 or 9 down to 2. And as you continue to navigate away from the device, or from the center, you can see we can get that error down to really a really low number. Now, the important part that I wanted to impress in this is that while we're doing this in a sort of a discovery mode of interacting with the data and understanding how different factors affect the accuracy and the thing that we want, on the lower left, we're actually generating rules. These are things that we would then drive through the automation to say, well, if that's the desired effect that we're looking for, then we need to make sure that that temperature is within, or those different sensors are within those ranges. So now we've automated the process of analyzing a large data set, giving you a way of going through some what-if scenarios to determine what you want to do, and get directly down to the rule sets that you would then enforce in the rest of the solution. There's other things that we can do with this diagram as well. So let's say, we wanted to understand, or we wanted the temperature to be within a particular range that we define. So let's say we wanted the temperature of that nozzle to be between 40 and 44 degrees for a reason that we determine is good. Then this gives us an easy way to navigate and say, any of these blue areas are things that are going to give you a prediction within that range. Again, automating the idea of here are the conditions that you need to look for, and then being able to automate those into the thing. The other way that we can use this diagram is to say, well, how about something like just understanding, that error rate. Maybe we've got a reason where we need to keep that error rate between, 0 and 1.6. Then we can use this diagram again to do the same thing, and any of these areas in pink are going to give you the ability. Now, what's interesting about this and why this is important, especially in embedded systems and devices, is it's great that the data can tell you something. It could say, gosh, if you could make that syrup temperature 500 degrees, it's going to solve your problem. Well, what if the hardware doesn't do that? It's great that the data told you that that's what you're supposed to do. And so the reality is, in many of these situations, and the reason why you need to go through this kind of a scenario is you may not have control to change the things. And so by navigating through these different rings and areas of the diagram, you're able to drill in and understand the things that you do have influence for and figure out, A, whether you're able to enforce those in the solution today, or whether or not that's something perhaps that you feed back into the R&D process to make the next revision of that sensor or the control system or whatever it is that you're trying to manage able to do that. So, hopefully you think that's cool stuff. Because for us at BSquare, the customers that we're talking to are all very excited about the types of things that we're able to do and the solutions that we can provide. And for us, it's not just about talking about the possibilities of what IoT can do, but it's really leading customers down that path to really deliver those real-world solutions today, and doing it in a combination of two things. One, bringing our DataV product and IoT stack as part of the solution, but secondly, also bringing in our long history and professional services to deliver a complete end solution to the customer. So with that, I think that's my time for today. We're going to be over, BSquare has a booth over on that side of the conference. Be happy to have some more conversations, and I hope that you enjoy the rest of the show. Thank you.